Assalamu alaikum everyone. Today we will be discussing the most recent Edexcel A-Level Mechanics 1 question paper. This paper is from October 2025. So bear with us as we go through every single question with precise and detailed explanations. So this is our question number 1. In this question we see that we have a beam and the beam has a weight of 240 Newton and the beam also has a length of 8 meters. We also see that beam is a uniform rod. As the beam is a uniform rod, the center of mass of this beam will be at the center of the beam. We also see that the tension in the rope at point D is given as 90 degree. There are two ropes at point C and other at point D. The tension in the rope at point D is given as 90 newtons. Now it is given that the beam is in equilibrium, and upon considering that we have to show that x is equal to 2 by 3. X here is the length of dB. So in order to do part A, we can first consider the information given here. So we have the beam here and there are two ropes at point C and point D. The two ends of the beam are called A and B, and the point C and D have two ropes. One of the ropes, our rope at point D, has a tension of 90 newtons and the beam has a weight of 240 newtons and the weight is acting at the center of the beam. As the length of the whole beam is 8 meters, the distance of the center of mass is 4 meters from both ends. And we know the whole beam has a length of 8 meters. From the question, we also see that AC has a length of 2 meters and DB has a length of x meters. And we have to find the value of x. We have to show that the value of x is 2 by 3 for our question number 1. So from all the information given, we see that in order to find the value of x, we can consider taking moments at the point C. If we take moments at the point C, we have to take into account our force of tension. We have to also take into account the force of weight. So when we do that, when we consider the moments due to the 90 Newton force and due to the 240 Newton force, we will see that in our moment equation, we will have x as a variable, x as an unknown. So from that we can calculate the value of x. From that equation we can find the value of x. So this is the plan here. We are taking moments about our point C. So we know that the beam is in equilibrium. As the beam is in equilibrium, taking moments about point C, when we are taking moments about point C, we will see that the clockwise moment about C is equal to the anti-clockwise moment about our point C. So we write as beam is in equilibrium, we are taking moments about point C. We know that as the beam is in equilibrium, that anti-clockwise moment would be equal to clockwise moment. So what is the anti-clockwise moment here? The anti-clockwise moment is due to the 90 Newton force. Sorry, 90 Newton force. So the force is 90 Newton. We know that moment is equal to force into perpendicular distance from the pivot. The pivot is our point C. So the perpendicular distance for the tension is CD. Now for the clockwise moment, the clockwise moment is caused by the 240 Newton weight of the beam, and the distance of the weight from our point C is given by 4 minus 2. If we see in the diagram, we will see that the distance of the 240 Newton force from the point A is 4 meters and the distance of C from point A is 2 meters. So subtracting 4 minus 2 gives us the distance between our point C and the weight of the beam. Now we also need the length of CD. In order to find the length of CD, we only need to consider these forces. So in order to find the length of C and D, we can subtract 2 and x from 8. Subtracting 2 and x from 8 will give us the value of CD. So we see that CD is actually equal to 8 minus 2 minus x, which is 6 minus 6. So now, if I rewrite this equation, we have 90 into 6 minus x, and we have 240 into 2. Simplifying this gives us 540 minus 90x is equal to 480. And from this, we get x is equal to 480 minus 240, 540, I'm sorry, 540 divided by minus 90. And this simplifies to x equals to 2 by 3. So we have shown this. For part A, we have shown that x is equal to 2 by 3. And this is the answer to our part A. We can now move on to the part B. For part B, we see that a package of weight W newtons is placed on the point A. It is also given that the rope at point C will break if the tension exceeds 183 Newton. Also given is that the rope at point D cannot break. Now, it is given that the rope at C does not break. So what we see from here is that when a package of W newtons is placed on our beam at point A, the rope C does not break. We know that the limit of tension in rope C is 183 Newton. So as the rope C does not break, what we understand from here is that when the weight is placed on our point A, the tension in the rope C is either less than 183 or is equal to 183 newtons. Now for part B, we see that we have to find the greatest possible value of W, the weight. So again, from the information, we understood that the tension in the point C must be equal to or less than 183 newtons. From the question, we see that it is given that rope C does not break. As rope C does not break, the tension at rope C is either equal to or less than 183 newtons. This is what we derive from the information given in the question. Also, it is said that we have to find out the greatest value of W. If we want to find the greatest value of W, what we can do, we can see the diagram for a bit. So this is our diagram, this is our point C, and this is our point D. This is C, this is D, this is A, and this is B. So this is the tension at point C, and this is the weight that is placed on our point A. And this package has a weight of W newtons. And we know that there is already the weight of the beam here, which is 240 newtons. The distances will stay the same. Now we see that as a package is placed on our point A, the tensions in point C and point D will be different. So in the part A, we saw that the tension in the point D is 90 Newton. This will not be the case here. We do not know the tension at D here. We do not know the tension of D in this place because the weights have changed. As the weights have changed, the tension in the ropes will also change. But we see in the question that we have to find the greatest possible value of the weight. We know that when the weight of the package is maximum tension occurs at our point C. We know that for different weights, the tension at rope C and rope D will differ. But the greatest possible weight is the weight at which the tension at C is maximum. So from this we can say that the greatest possible weight will occur when the tension at C, TC, the tension at the rope C will be maximum. So from this we see that in order to find out the maximum weight, we have to consider TC as 183. So in our case, as we are trying to find the greatest possible value of W, we will consider TC as 183 newtons. Now we can do the math here. So the distances are the same. We know the distances here. This was 2 meters. This is X, or 2 by 3 as we calculated from the previous part, and we still know that the whole beam is 8 meters. As we do not know the tension at D, we will not consider the vertical forces, but instead we will take moment from point D. We will take moment at point D. Taking moment at point D will require us to use the value of tension at C and use the value of weight at weight of the beam and weight of the package. So from that we can easily find out the value of W. As we know all other variables, we can easily find out the value of W because that will be the only unknown in our whole equation. So we know that the beam is in equilibrium. When the weight is maximum, the beam is in equilibrium. The beam is still in equilibrium. So we can still say that the clockwise moment is equal to anti-clockwise moment around our point D. So again, the clockwise moment, anti-clockwise moment is equal to the total clockwise moment. Anti-clockwise moment here again will be due to the weight of the beam and the package. So we have W into AD, and we have 240 into 4 minus X. So for the distances, we already have the forces. The forces are W and 240 newton. In order to find the perpendicular distances from the pivot, we see that for W, the distance from the pivot is AD. We can calculate it later on. But for the weight, we see the distance required in the moment calculation is this distance. As the pivot is D now, we have to consider this distance as the distance from the pivot. So this distance is equal to 8 meter minus 2 by 3. This distance is equal to, this distance is equal to 4 meters minus 2 by 3. We know that the weight is in the center. The weight is 4 meters from our point B. So we can just write the distance as 4 minus 2 by 3. And this is our anti-clockwise moment. Let us now consider the clockwise moments. The clockwise moments are, the clockwise moment is due to the tension at point C, which is 183, and the distance of C to D is 6 minus X, which we will show in the next step. So now this simplifies to, we have W into 8 minus 2 by 3. We see that AD is basically 8 minus 2 by 3. AD is basically 8 minus 2 by 3. This whole distance AD is basically equal to 8 minus 2 by 3. Then we have 240 into 4 minus 2 by 3, which is 10 by 3. Simplifying this will give us the value of W. So we have 83 into CD. From the previous part, we know that CD is 6 minus X. We already know the value of X, which is 2 by 3. So this is 6 minus 2 by 3. So ultimately, in order to find the value of in order to find the value of weight, we can simplify this as and we have here 183.24. The maximum possible weight of the package is 24. Our package cannot exceed this weight because if the package is heavier than this, the tension at rope will exceed 183 and the rope will break. So this was our question number 1. We can now move on to the question number 2. This is our question number 2. We can see that we have two particles here, particle P and particle Q. Particle P has a mass of 7m and particle Q has mass of 3m. And both particles are moving toward each other. They're moving in opposite direction along the same straight line. The surface they are moving on is smooth, so there are no friction forces on them. Now it is said that the particles they collide directly. Immediately before the collision, the speed of P is ku and the speed of Q is u. This is before the collision. Immediately after the collision, the speed of P is w and the speed of Q is 2w. It is also said that the direction of motion of Q is reversed by the collision. So we know the direction of motion of Q before and after the collision. We do not know anything about the direction of P after the collision. Now it is given that the impulse received by Q in the collision has a magnitude of 7 by 2 mu. In part A, we have to find W in terms of U. We have to find W in terms of U. We can see from our question that W is the velocity after the collision for both P and Q. For P it is W and for Q the speed is 2W. Now if we consider the impulse received by Q, we see that the impulse received by Q is 7 by 2 mu and we can use this information to find out the value of W. So from the question we see that the particle Q experiences an impulse of 7 by 2 mu. The impulse received is in this direction and the impulse has a magnitude of 7 by 2 mu. This is given in the question. We also know that Q has a mass of 3m and it is also given that Q was traveling in this direction before collision, and before collision the speed of Q was u meter per second. In the same it is also given that after the collision the direction of motion of Q was reversed and the new speed is 2w. So now we can use this information to form an equation using impulse and the before and after momentums. We know that impulse on Q will be equal to the change in momentum of Q. So we know the impulse on Q and we also know the change in momentum of Q. So we can form an equation using this. So for the change in momentum of Q, we know that the change in momentum of Q is basically momentum after minus the momentum before. We will calculate the momentum after the collision for Q and before the collision for Q, and we will subtract that. So momentum after collision is equal to mass into velocity after the collision. So we have mass of 3m and velocity after the collision is 2w, and we subtract momentum before the collision from this. So momentum before the collision is 3m, the mass, and u. The direction of u, the velocity before the collision will be negative. The reason for this is I have considered this direction as the positive direction. So this makes our initial velocity negative. So I've used minus u here. Now we simplify. Now we will make W the subject of this formula. We have 7 mu minus 3 mu is equal to 6 mw. So W is equal to 7 by 2 minus 3 mu divided by 6m, and we can cancel out m from the bottom and the top of the fraction. So this gives us w as 1 by 12u. So this is w in terms of u. This is our answer to part A. Now for part B, we see that we have to find out two possible values of k. Now k is the speed of u before the collision. The speed of p before the collision was ku. We can see on the diagram that the speed of p before the collision was ku. So if we want to find the speed of p before the collision, we need to consider the motion of p, and we need to consider the equations for the motions of p. So in order to do that, we will have to consider the motion of p before and after the collision. In part A, we considered the impulse on Q. We know that the impulse on Q and the impulse of P would be the same. We know that whenever there is a collision, the momentum is conserved. The linear momentum is conserved, and as the momentum is conserved, moment impulse on one of the particle is equal to but opposite in direction of the other particle. So if impulse on our particle Q is 7 by 2 mu, we see this in part A. The impulse on particle P will also be 7 by 2 mu, but this will be in the opposite direction. So we can consider this impulse on particle P to calculate our constant K. But there is a problem here. The problem is that we do not know the direction of motion of P after the collision. There are two possible directions of P after the collision. See, there are two possibilities. We know that before the collision, particle P has a velocity of ku. We also know that the particle P has mass of 7m. Yes, I'm correct. It's 7m. And we also know that the impulse on the particle P will also be the same in both of these scenarios. Impulse is in this direction, and impulse is equal to 7 by 2 mu. The magnitude is equal to this. Now, for the velocity after collision, we know that the magnitude of the velocity, the speed, is given as w. The speed after collision for p is given as w. We know the speed, we know the magnitude of the velocity after the collision, but we do not know the direction p is traveling after collision. So there are two possibilities here. The first possibility is that after the collision, p is traveling in the same direction as before. Its direction has not changed. This is our possibility 1. And there is one other possibility that the direction of p has also reversed, like q. So these are the two possibilities. Now for these two possibilities, when we consider these two possibilities, we will find that from these two possibilities we will have two different values of k. So this is what is referred to in the question here. In the question we have to find out two possible values of k. So this is what it is referred here as the two possible values of k. So now what we will do, we will consider these two scenarios, and we will find the value of k distinctively for both of the scenarios. So this is our scenario 1, this is our case 1, and this is our case 2. Now for case 1, again we will follow the same process as our part A. We will consider the impulse on our particle P. We know that the impulse on our particle P is equal to the change in momentum of particle P. So we know that the impulse on particle P is 7 by 2 mu. The direction of this impulse will be negative. See, if we consider this direction as the positive direction, we see that impulse is applied opposite to this direction, so impulse will be negative. So minus 7 mu will be equal to mv minus mu. So change in momentum is equal to momentum before the after the collision minus momentum before the collision. So this would be equal to p before minus p after. And that will be equal to, I'm sorry, this would be p after minus p before. So in this case, in case 1, the momentum after the collision is equal to mass, which is 7m, into velocity after the collision. Velocity after the collision is w in the positive direction. And then we subtract the initial momentum, which is mass, into ku. Again, ku will be positive because we have considered that direction positive. So we have this here, and we will simplify, and we will just make k the subject of this formula. From part A, we also know that W is equal to 1 by 12U. So we can substitute 1 by 12U in place of W here. So again, just simplifying this, we get 7 by 12 mu minus 7m ku. Bringing all the mu terms together, we get this as the simplified function. If I make k the subject here, so we will get 7 by 2 minus 7 by 12 mu divided by minus 7 mu. From the calculator, we see that this is equal to 7 by 12. So k in our case 1 is 7 by 12. Now if we consider case 2, our process will be exactly the same, but the direction of velocity, the final velocity after collision, would be just different. So again, this is case 2. For case 2, we are going to do the same thing. We know that the impulse on particle P will be equal to the impulse on particle Q, and the impulse on particle P will be equal to the change in momentum of particle P. So again, we know that the impulse is minus 7 mu. Again, we see that we have considered this direction as the positive direction. So we will consider 7 mu as negative. The reason we are considering the impulse negative is because the impulse is in the opposite direction of our assumed positive direction. We have assumed the forward direction as positive, so the impulse will be considered negative because it acts in the opposite direction. For the change in momentum, we are going to subtract momentum before from momentum after. So momentum after collision in this case would be, if I zoom out a little bit, momentum after for this case would be 7m into minus w. See, the velocity after the collision for in this case would be negative. In the previous case, w was positive. In this case, the w is negative. And this is the difference here. And then we subtract momentum before, which as usual is 7m into ku. Now we just have to simplify and find out the value of k. Again, we see from our part A that w is equal to 1 by 12 u, and then we can just simplify this. Now if we simplify, we find the value of k as minus 7 by 2 plus 7 by 12 mu divided by minus 7 mu. Again, from the calculator, we see that this is equal to 5 by 12. So the two possible values of k would be 7 by 12 and 5 by 12. These are the two possible values of k. The reason why there are two possible values of k is because there are two possible velocity after the collision. The velocity after the collision, the magnitude of it is constant, but the direction is unknown. There could be two directions for the velocity after the collision. That's why we have two different values of k. So this was our question number 2. We can now move on to the question number 3. So this is our question number 3. In this question, we have a particle P that has a mass of 2 kg, and that particle is moving on a smooth horizontal surface. It is also given that the particle has two forces on it, forces F1 and F2, and F1 and F2 are given using I and J vectors. In part A, we have to find the acceleration of P. We know that the acceleration of a particle depends on the resultant force on it. We know that force on a particle is equal to the mass and accelerate into its acceleration. So from this we can find out the acceleration of our particle P. We just need the resultant force on our particle. Now to find the resultant force on our particle, we just have to add the two forces on our particle together. We can get the resultant force by adding the two forces together because the forces are given in I and J vectors. This is one of the advantages of expressing the forces in I and J components, because expressing them in I and J components is similar to expressing them in horizontal and vertical components. So whenever we are adding two forces that has been expressed in I and J components, we are basically adding their horizontal and vertical components together. So adding two forces that has been expressed in I and J components is the same as adding the two forces to find a resultant force. So that's why adding the two forces that are expressed in I and J components gives us the resultant force. In our case, we can represent our F1 and F2 force on an axis. So we know from the question that F1 is equal to minus 2 and 3J. So the F1 force is like this. The horizontal component of F1 force is 2 minus 2, and the vertical component is 3. In the same way, F2 can be represented in the diagram. The F2 force has a horizontal component of 4I and 2J. So adding the two forces will give us the resultant force. Adding the two forces together will give us the resultant force. So the resultant force is equivalent to F1 plus F2. Then on the right side we have mass into acceleration. We know the mass of the particle is 2 kgs and acceleration is unknown. So from this we can find out the magnitude. We can find out the acceleration vector. So we have F1 and F2 divided by 2. So we know that F1 is equal to minus 2I plus 3J, and F2 vector is equal to 4I plus 2J. Now simplifying this, we see that simplifying this gives us 2I plus 5J. Now we have to divide this by 2. Dividing this by 2 is same as dividing each of the coefficients of each of the I and J component by 2. So this will simplify to I plus 2.5J. And this is our answer to our part A. Now for part B, we see that the initial velocity has been given. For part B, we see that the velocity of our particle P at time equals to 0 has been given. So this is our initial velocity of the particle. Now in our question number B, we have to find the speed of the particle when time equals to 3 seconds. We know that there is an acceleration of the particle, so the speed of the particle will increase each second. We already know the initial velocity. We just have to find the velocity after 3 seconds, after acceleration has been acting on the particle for 3 seconds. So from the information, we know that the particle is on a smooth road and there is an acceleration on the particle. The acceleration has a magnitude of I plus 2.5j, and the ball has an initial velocity of 3I minus 4j. And we have to find the final velocity of the ball when the ball has when 3 seconds has been passed. So we have to find out the final velocity of the ball after 3 seconds. So we see that we have some information here. The information are that the information are the initial velocity 3I minus 4j. We have the acceleration I plus 2.5j. We also have the time, which is 3 seconds. And we have to find the final velocity. What we see here is that acceleration is constant. As acceleration is constant, we can find the final velocity using one of the constant acceleration formulas. So the formula uh, that connects all these four variables together, all these four quantities together, is v equals to u plus at. We see that in this formula, v, u, and a are all vectors. That's why I have written them using underscores. Now I will substitute their values in the equation. So we have u as 3I minus 4j, then we have acceleration as I plus 2.5j, and we have time, which is equal to 3. Simplifying this gives us 6I and minus 3.5j. I'm sorry, plus 3.5j. This is our final velocity. But this is not our answer, because in the question we see that we have to find the speed of p. In the question, it is said that we need to find the speed of p, not the velocity. Velocity is a vector, but speed is not a vector. Speed is the magnitude of the vector. So we have the velocity, we just need to find the magnitude of the velocity vector to find the speed of p. So in order to find the speed of p, we just need to find the magnitude of our vector v. To find the magnitude, we just use Pythagoras theorem, and that will give us 6 square plus 3.5 square inside the root. Ultimately, this is equal to 6.95 meter per second. So the speed after 3 seconds is 6.95. This is our answer to part B. We can now move on to our part C. We can see that for part C, we have some additional information. So it says in the question that there is an additional force. The additional force is called F3, and F3 is given as Bi plus Cj. And this force is also applied to our particle. It is also given that the resultant of the three forces is equal to lambda I plus j newtons, where lambda is a constant. In part C, we have to show that B minus C is 3, where B and C are the coefficients of F3. So for part C, we already know that there are two forces acting on our particle P. Now there's a third force, F3, that also acts on our force. So we have F3, and F3 is equal to F3 equals to Bi plus Cj. Again, in order to find the resultant of the three forces, we just need to add the three forces together. Again, the reason for this is that the three forces are expressed using I and j vectors, so we can find the resultant of these vectors by just adding the vectors together. So F1, F2, and F3, when added together, gives us the resultant force. And we know from the question that this would be equal to lambda I plus j. So let us calculate the resultant force first. So we know that F1 is equal to minus 2I plus 3j. And we also know that F2 is equal to 4I plus 2j. And we also know that F3 is equal to Bi plus Cj. Now if we want to simplify this, we can collect all the coefficients for I, and then we can collect all the coefficients for j. Doing this for I, we get minus 2 plus 4 plus b as the coefficient of I, and for the j we get 3 plus 2 plus c as the coefficient of j. So from this, after simplification, we get 2 plus bi and we get 5 plus cj. And this is our resultant force. This is the resultant force. We know that the resultant force would be in this format, lambda I and j, and as this is given in our question. So what we see from here is that the coefficient of I and the coefficient of z would be the same. So we know that it is given the resultant force is equal to lambda I plus j. We know this from the question. So if we expand this, we see that the coefficient of I and the coefficient of j are equal. It is given in the question that the resultant force will be in this format, and in this format we see that the coefficient of I and the coefficient of j are equal. So what this shows us that the coefficient of I and uh, j here will also be equal. So what this shows us is that 2 plus b will be equal to 5 plus c. So we can say that the coefficient of I and j are equal. We reached this conclusion from here. So now we can say that 2 plus b is equal to 5 plus c. So from this, we can bring c to the left side, and this gives us b minus c, and we can take 2 to the right side, and this gives us 5 minus 2. So from this, we can simplify, and we get b minus c is equal to 3. And this was our question. Our question was that we have to show b minus c is equal to 3, and we have shown that b minus 3 is equal to 3. So this is our answer to our part C. Now for the part D, it is given that the resultant of F1, F2, and F3 has a magnitude of 10 root 2. Now we have to find out two possible forces, two possible F3 forces. So we already know that the resultant force is given by this vector, the vector we calculated in our part C. We know that the resultant force is given by this vector here, which is 2 plus b I and 5 plus c j. So now we see that in our question, it is given that this resultant vector has a magnitude of 10 root 2. So if we find the magnitude of this resultant force, the magnitude of this resultant force when calculated from this equation would be like this. We are following the general procedure for calculating the magnitude of a vector that is given in I and j form. So the general procedure is that we take the coefficient of I and then we square it, and then we add the coefficient of j by squaring it, and then we root the whole thing, and this will give us the magnitude of the resultant force. We also know from the question that the magnitude of the resultant force is equal to 10 root 2. So now we have an equation. Now simplifying this expression will give us another equation in b and c. So this will give us a second equation that contains b and c as unknowns, as unknown values. So see what we can do here, we can square both the sides, and that will eliminate the square root from both sides. So squaring both sides will give us 10 root 2 whole square, and on the right side we have 2 plus b whole square and 5 plus c whole square. Now we can expand these individual brackets. Expanding this gives us 4 plus 4b plus b square, and expanding 5 plus c whole square gives us 25 plus 10c plus c square. Expand now calculating 10 root 2 whole square gives us 200. Now we can bring all the terms to the right. Or maybe we should not expand this. Maybe it is best if we keep it like this. It becomes much more concise, and uh, is much less work like this. So see, we have a second equation here, and the equation in our question C was our first equation. So in order to find the F3 force, we need to find the value of B and C. So in order to find the value of B and C, we are going to use these two equations, our equation 1 and equation 2, and we need to solve them simultaneously. So how can we do that here? We can use the substitution method. In order to do the substitution method, I'm going to choose our equation 1. Our equation 1 was like this: B minus 3 is equal to 3. And from this, I can isolate B, and this gives us 3 plus C. This is our expression 3. Now I'm going to substitute this equation 3 into our equation 2. I'm going to substitute 3 plus C in place of B. So we have 200 is equal to 2 plus B whole square. We are going to substitute 3 plus C instead of B. And then we have 5 plus C here. And this is also whole square. Now simplifying this gives us 5 plus C whole square plus 5 plus C. And this is equals to 200. And we can simplify this as 2 5 plus C whole square equals to 200. Now from this we see that 5 plus C whole square is equal to 100, and 5 plus C is actually equal to root over of 100. Now as we have taking the square root of both sides, the value here could be plus or minus. Both of these will satisfy our equation. So from this we see that C is actually equal to minus 5 plus minus 10, which is minus 5 plus 10 or minus 5 minus 10. So C could be equal to 5 or C could be equal to minus 15. There are two possible values of C. So we now have the value of C. We also need the value of B in order to find the force 3, F3. In order to find the value of B, we need to use the value of C and put that value into our equation 3. So we are using the value of C and we are putting this value into our equation 3. The equation 3 was like this. The equation 3 was B is equal to 3 plus C. So now we see from here that B will be equal to 3 plus 5 or 3 minus 15. Again, for B we have two values. 3 plus 5 is 8 and 3 minus 15 is minus 2. So there are two values for B. So from this we see that there are two sets of values for B and C. We see that B is equal to 8 when C is equal to 5, and we see that B is equal to minus 12 when C is equal to minus 15. So from this we can find out our force F3. We know that force F3 is equal to Bi plus Cj. So we can just use each pair of our B and C values to to find to construct the two possible values of our force 3. So one of the possible values is 8I plus 5J. The other possible value is minus 12I minus 15J. So these are the two possible values for F3. Both of these values are possible. Both of these values can be the force 3 here. And both of these values can bring out the same results here. Will give the same results as this ones. So this was our question number 3. We can now move to our question number 4. So this is our question number 4. In this question, we see that we have a particle P that is projected vertically upwards with a speed of 5 meters per second. And the particle is projected from point A. And point A is vertically 10 meters above the horizontal ground. We also see that P moves freely under gravity. Now, for our question number A, we have to find the greatest height above A reached by our particle P. So from the information given, we see that there is a point A and there is a particle at point A. The particle is called P. This particle is projected vertically upwards from this point. And the speed is 5 meters per second. As the particle is vertically moving upwards, there will be a gravitational acceleration force, acceleration on the particle, and the acceleration will be downwards. We also see from the question that this point A is vertically 10 meters above the horizontal ground. We see here that there is an acceleration on the particle in opposite to the initial velocity. The acceleration is downwards. So what this means is that the speed of the particle will decrease as it rises up. At a certain point, the speed of the particle will become 0, and that is the point at which the particle will have the maximum height. The point at which the velocity of the particle is 0 is the point in which the particle has the maximum height. And this is the height we need to find. This is the maximum height we need to calculate in our part A. So let's see what information we have here. We have the initial speed, which is 5 meters per second, initial velocity, and then we have the acceleration. The acceleration acts opposite to the initial velocity. The acceleration is opposite to the initial velocity given here. So it is minus g. We also see that velocity is 0. The final velocity at the maximum height is 0. So velocity is 0. And we have to find the displacement here. So we see that acceleration is constant here. As acceleration is constant, we need to use one of the constant acceleration formulas to calculate the value of s. So the equation that connects all these quantities together is v square equals to u square plus 2as. From this, we can calculate the value of s. As we need to find the value of s, I can make s the subject of the formula here. So making x the subject of the formula, we get v square minus u square divided by 2a. We get v square minus u square equals to 2as. From this, we see that s is equal to v square minus u square divided by 2a. Now, if we substitute all the values, we get v square minus u square, which is 5 square, divided by 2 into minus g. G here is 9.8, so minus 9.8. From this, we get 125 divided by 98 as the maximum height. This is the maximum height. Above our point A. The maximum height reached by our particle P above the point A is 125 by 98. So this was our part A. Now for part B, we see that in part B, we see that there is another particle Q. And particle Q is projected vertically upwards with a speed of 7 meters per second. Particle P was on the point A, but particle Q is on the point B, and point B is on the ground. Now we also see that particle Q is projected vertically upwards at time equals to 1 second. Our particle P was projected at time equals to 0, and particle Q is now projected at time equals to 1 second. Now it is given that particle P and particle Q, they collide at time equals to t seconds. We now have to find the value of t. For part B, we just have to find the value of t here. So let's see what information we have here. So what we see here, there is another particle, particle Q. And particle PQ has an initial velocity of 7 meter per second, and it is projected upwards. Particle Q is on the ground, and we already know from our previous question that point A is 10 meter above. We know that particle P has been projected from point A, and particle P will move up and will reach its maximum height, and then it will fall down again. At some point, particle Q and particle P will collide together. So we know that when two particles they collide together, they are at the same distance. If you see from here, this height is 10 meter from the ground. We know that this height is 10 meter from the ground. As this is the initial point for our particle P, we calculate the displacement of particle P from this level. And as particle Q is on the ground, we calculate the distance of the displacement of particle Q from the horizontal ground. So there are two possibilities here. One of the possibilities is that particle P and particle Q, they collide above this line, Let's say they collide somewhere here. In that case, the displacement of A would be given like this, given from this. This is displacement of A. And the displacement of Q would be given like this. This is displacement of A. And this is displacement of Q. If the particles collide above that line, the displacement of A is given like this, is the smaller arrow, and displacement of our particle Q is the bigger arrow. The displacement of our particle P is this, and the displacement of particle Q is this. If the particles they collide above the 10 meter line. But if the particles they collide below this line, let's say they collide below this line, let's say they collide somewhere here. If they collide somewhere here, let's say the two particles have collided somewhere here, then the displacement of particle A is given by this, and displacement of particle Q is given by this. So in both of the scenarios, we see that the displacement and displacement of A, the displacement of P, displacement of P and the displacement of Q, they add up to 10 meters. So we can form an equation, or we can form a relationship between SP and SQ from this observation. So let's see. So let's say if the particles they collide above the 10 meter line, this is the 10 meter line. So if they collide above this point, the displacement of P is SP and the displacement of Q is SQ. This one. So we see from here that subtracting SP from SQ gives us 10 meter. We can see from here that subtracting SP from SQ will be equal to 10 meter. In the same way, let's consider when the particles are colliding below the 10 meter line. At this point, let's say they're colliding at this point. So the SP, the displacement of P particle would be this, and the displacement of Q particle would be this. So in this case also, we see that SP is pointing downwards and SQ is pointing upward. So in this case also, we see that adding them two together gives us 10. So let me add them together. So SP minus SQ. Oh, sorry, we can consider SQ positive. So we have SQ and minus SP. This one is minus SP. See, this one is minus SP. Why is this negative? Because SQ is positive. That's why SP is negative. We can also consider SP positive and SQ negative. The answer would be the same. So we see that in both cases, wherever our particle collides, the equations are the same. So we can say that when the displacement of particle P and the displacement of particle Q have this relationship. They have this relationship. They have this relationship. So we can write that SQ is equal to 10 plus SP. So now we just have to find out the expressions for SQ and SP, and from that we can find out the value of T, time at which this happens. So let's see. So the expression for SP would be the expression for SP. Uh, we have to consider the information given to find out the SP values. So we have initial velocity for P, which is 5 meter per second. We have acceleration for P, which is minus g. So we can use this to write an expression for our SP, the displacement of P. So SP is the displacement of P and SQ is the displacement of our particle Q. So we know that the time at which the particles collide is T. So we can write, so we can use the formula as displacement is equal to half ut plus half it square. And if we substitute the values here, we have 5t minus half gt square, and this is the expression for the displacement of our particle P. Now we have to find an expression for our particle Q. In order to find an equation for the particle Q, we have to use its information. So we know the initial velocity of the particle is 7 meter per second, of our particle Q is 7 meter per second, and we know the acceleration is in the opposite direction, which is minus g, and we know the time at which the two particles will collide is t minus 1. So we know that the two particles, we know that when the two particles are not being projected vertically upwards at the same time, particle Q is delayed by 1 second. As the particle Q is delayed by 1 second, we have to subtract 1 to make sure that their equations are correct. We have to subtract 1 to make sure that their equations are correct. So we are subtracting 1 from t. So again, using ut plus half it square, we get an expression for displacement. U is 7, and then we have t minus 1, and then we have minus half gt square, minus half gt square. This is SQ. So if we now see the expression we derived here, we know that SQ is equal to 10 plus SP. So from this expression, we can relate the two quantities we derived. So SQ is equal to 7 t minus 1 minus half g t minus 1 whole square, and then we have 10 plus SP. Now displacement of P, we derived the expression for displacement of P, and displacement of P is 5t minus half gt square. Now we can expand and solve the equation to find the value of t. So expanding them, we get 7 minus 7, and then we have minus half g. Inside the brackets, we have t square minus 2t plus 1. Upon further simplification, we'll get an quadratic equation which will be equal to 70. We have 70 minus 7, and then we have half g t square minus From this we can simplify it. So we have we see that we have the same terms here. We have minus half gt on the right and the left side, so we can cancel them out. And then we have 7t minus 5t plus gt, and this is equal to 10 plus 7 plus half g. So ultimately t is equal to 17 plus half g and divided by 2 plus g. So this is equal to 1.86. So we see that the time at which the two particles collide is 1.86 seconds. So this was our question number 4b. We can now solve the part C here. In part C, we have to find the speed of P at the instant immediately before the particles collide. So we already know the time at which the particles collide. We just have to find the velocity of the particle P before the time of collision, before the collision. So let's see. So in part C, we will consider the information we know. So we know the initial velocity for particle P, which is 5 meters per second. We know the acceleration for particle P, which is minus g. And we know the time at which the particle P collides with particle Q, which is 1.86 seconds. And we know that we have to find the final velocity. So again, we know that this is acceleration is constant, so we can use the constant acceleration formulas. So the formula that relates all these quantities together is v equals to u plus at, and from this we can find the value of v. V we know is equal to u plus at, so 5 plus 80, this is minus g into t, 1.86. 5 minus 1.86 into 9.8, and this gives us minus 13.2 meter per second as the velocity of the particle p. Now we see in the question that we have to find the speed of the particle. So the speed of the particle is the speed of p is basically the magnitude of this value. So 13.32 is our answer. This is the answer to our question number 4. So this concludes our question number 4. We can now move on to the next question here, our question number 5. So this is our question number 5. We have a box of mass 4 kg and the box is placed on a rough horizontal surface. The surface is rough, so we need to consider friction here. It is also given that a force of magnitude p newtons acting at 30 degrees to the horizontal is applied to our box. And the coefficient of friction between the box and the surface is also given as 2/3. Now for part A, we have to find the value of P when the box is on the point of sliding along the surface. So we have to find the value of the force when the box is on the point of sliding along the surface. So when the box will be on the point of sliding, we know that whenever the box is on the point of sliding, the horizontal force would be equal to the maximum friction force of the surface. So if we see what forces are there on our box, we are considering the box as a particle. So our box has a force of P on it, and that force is acting at 30 degrees to the horizontal. As our force is acting at an angle, this force will have two components, one horizontal component and one vertical component. To find the magnitude of the horizontal component, we can take the magnitude of our original force and we can multiply it with cos of 30. And to find out the magnitude of the vertical force, we can multiply the magnitude of our original force with sine of 30. This is how we get the components from the original force. We also have a friction force here due to the surface. The friction force will act opposite to the applied force, will act opposite to the horizontal component of the force. We know that friction always act or tries to oppose motion. So our particle will try to move to the right. That's why the friction force is to the left. If our particle was moving to the left, the friction force would be to the right. So friction always opposes motion. That's why the motion would be towards the right. That's why the friction is acting here to the left. We also have a reaction force acting upwards on our particle, and there is a weight of the particle acting downwards. The mass of our box is 4 kg, so the weight would be 4g. We can erase the original force because we have already resolved the forces into components. So this is the force diagram for our box. So we see that the particle will be vertically balanced. There will be no vertical motion because all the vertical forces, they cancel out. And as the particle is in equilibrium, the horizontal forces will also balance out. A condition given in our question is that the particle is on the point of sliding along the surface. We know that when the particle is on the point of sliding, the horizontal force will be equal to the maximum friction force provided by the surface. In this case, we know that the the horizontal force P cos of 30 would be equal to the maximum friction force provided by the surface. So we know that maximum friction force is equal to mu r, where mu is the coefficient of friction and r is the reaction force. So from this we can find out the value of P. So what we are trying to do here, we are trying to find the value of r and the value of mu in order to find the value of F max, the maximum friction. So in order to find out the value of the reaction force, we need to resolve the forces vertically. We need to resolve the vertical forces. We know that resolving the vertical forces will result in zero because the particle does not move vertically, it is in vertical equilibrium. So in vertical forces we have reaction force, which is upwards, and we also have P sine of 30, which is also upwards. And then we have the weight, which is acting downwards, so minus 4g. And resolving this gives us 0. All the vertical forces, they will add up to 0. So from this we can find out the value of our reaction force, which is equal to 4g minus P sine of 30. From the question we also know that mu, the coefficient of friction, is given as 2 by 3. Now we can use this to rewrite our question, rewrite our this expression as this. So we have 2 by 3 into r, which is 4g minus P sine of 30. So we have P cos of 30 degree equals to 2 by 3, 4g minus P sine 30. So from this, what we are going to do, we are going to find the value of P. To do that, we need to make P the subject of this expression. So what I'm trying to do here, we are trying to simplify this by expanding the bracket. So this will give us 8 by 3g minus 2 by 3 P sine of 30. We'll be bringing the P terms together. So this gives us P cos 30 plus 2 by 3 P sine 30. And this is equal to 8 by 3g. Now taking P common from both of these terms, this leaves us with cos 30 plus 2 by 3 sine of 30 inside the brackets and 8 by 3 on the right side of our equation. So P is given by 8 by 3g divided by cos 30 plus 2 by 3 sine of 30. So this will be equal to This gives us 21.8 newtons for P. This is our part A. So now for part B, we read, we see that the value of P is now increased to 25 and the box moves along the surface. Now for part B, we have to find the acceleration of the box. So we can use Newton's second law, F is equal to mass into acceleration, to find out the acceleration of the box. So we now see that the force P is now increased to 25. As the force P is increased to 25, its horizontal component will also increase. As its horizontal component will increase, the vertical component will also change. So the reaction force will also change and the friction force will also change. So we need to calculate all of them to find out the acceleration. To find out the acceleration, we need to find the horizontal resultant force. To find the horizontal resultant force, we need to find out the horizontal component of our force P and the friction. So we have the particle here and we see that the force is now increased to 25. So in order to find the horizontal acceleration, we need to find out the horizontal resultant force on the particle. And the horizontal resultant force would just be the difference between the forward force, that is the horizontal component of our P force, which is now 25. So this would be equal to cos of 30. And we have to subtract the friction force here. Now we do not know the friction force here because we know the friction force, the maximum friction force depends on the reaction force and the coefficient of friction. The coefficient of friction is the same because the surface has not changed, but the reaction force has changed. So the maximum friction force will also change. So we need to find out the reaction force here. In order to find the reaction force, we again have to consider the vertical forces. We see that there are two vertical forces acting upward here. One of them is the component of our 25 Newton force, which is 25 sine 30, and the other one is the reaction force, which we need to find here. The reaction force is the one we need to find here. And again, there is weight that is vertically acting downwards, and the weight is 4g. So what we can do here, we can resolve the forces vertically. We can resolve vertically, and this will give us r plus 25 sine 30 as the two upward forces, and we have to subtract the weight because the weight is acting in the opposite direction. Adding all these forces will give us 0 because the ball is in vertical equilibrium. So the addition of all the forces vertically will give us 0. From this we find the reaction force, which is 4g minus 25 into sine of 30. We know that sine 30 is equal to half, so this can be simplified to 25 by 2. Now we know the reaction force. From this we can find out the value of the maximum friction. So if we use Newton's second law and we have to resolve the forces horizontally. So we know that from Newton's second law, we know that resultant force is equal to mass into acceleration. The resultant force here is just the component of the force, the horizontal component of the force, which is P sine 25 sine of cos of 30. I'm sorry, it's cos of 30 minus the friction force. We know the friction force is equal to mu into r. Mu is 2 by 3. The coefficient is 2 by 3, and the reaction force is 4g minus 25 by 2. This is equal to mass into acceleration. We know the mass is 4 kg and we have to find the acceleration. So the acceleration is equal to 25 into root 3 by 2. Cos 30 is equal to root 3 by 2. So we can replace it with this. And then we have 4g minus 25 by 2. This whole thing will be divided by 4. And that will give us the acceleration of the block along the horizontal axis. This is equal to 0.96 meter per second square. This is the acceleration. So this is our part B. We can now move on to our part C. For part C, we see that we have to find the speed of the box when it has moved 1.5 meter. So we now know the acceleration of the box. As there is acceleration of this box, its speed will increase each second. So after traveling 1.5 meter, its speed will be completely different from the start as compared to the start. So we just need to find out the velocity after it has traveled 1.5 meter. Again, in this case, we know that the acceleration is constant. Then as the acceleration is constant, we can find out the final velocity for this particle by using one of the constant acceleration formulas. So let's see. For part C, the information we know is this. We know that the initial velocity of the box was 0. The box was initially 0. We know that the acceleration of this box is 0.96 meter per second square. We know that the box has traveled 1.5 meter, and we have to find the final velocity. So in order to find the final velocity, we have to choose an equation that has all these quantities together in it, and that equation would be v square is equal to 2 square plus 2as. So we have to find the final velocity. So if I make v the subject here, we have to root the right side of our equation, and this gives us u square plus 2as root over u square plus 2as. Substituting all the values gives us so the final velocity is 1.70 meter per second. So this concludes our question number 5. We can now move on to our question number 6. Bismillah. So this is our question number 6. In this question, we see that we have a velocity time graph given, and this velocity time graph is the velocity time graph for a motion of a car. The velocity time graph given maps out the velocity of a car during the first 35 seconds of its journey. This is given in the question, and the car is traveling on a horizontal straight road. Now for part A, we have to find the acceleration of the car for a period of 0 to 10. So we have to find out the velocity of the car between this period, between the period of 0 to 10 seconds. So we know that the gradient of the velocity time graph gives us the acceleration of the car. We see that within these first 10 seconds, the graph of the car is a straight line. We know that the gradient of the straight line is constant, so the acceleration is constant in this period. We also see that the gradient of this curve will be positive. So from this, we can say that the acceleration is also positive. The car is increasing its velocity. The car is accelerating. So in order to find the acceleration of the car between this period, what I'm going to do is we are going to find out the gradient in this 10 seconds. We have to find the gradient of the curve within this 10 seconds, and that will give us the acceleration. So for A1, we have to find the gradient. We know that the acceleration is given by the gradient of the curve of a velocity time graph. And we know that in order to find the gradient, we need to use the formula y2 minus y1 divided by x2 minus x1. To use that formula, we need 2 points on the graph. So one of the points I'm going to use is this one, and the other one is this one, the starting point. The starting point has a coordinate of 0 and 0. And after 10 seconds, the car will have a velocity of 30. So this coordinate becomes 10 and 30. So we're going to use these 2 points to find to calculate the gradient of this straight line, and that will give us the acceleration of the car within the first 10 seconds. So we know that gradient is equal to y2 minus y1 divided by x2 minus x1. So from the graph, we have the points 0, 0 and 10, 30. From this we calculate 30 minus 0 divided by 10 minus 0. So this gives us an acceleration of 3 meter per second square. So the acceleration of the car within the first 10 seconds is 3 meter per second square. The car is accelerating with a acceleration of 3 meter per second. Its speed is increasing by 3 meter per second each second. Now for A2, we see that we have to find out the deceleration of the car in the period 30 to 35. So within the 30 to 35 seconds, the car was decelerating, and we have to find out the magnitude of the deceleration here. We can see that within this period, the car has a graph that is a straight line. So again, the deceleration is constant. And as the graph has a negative gradient here, we see from here that the acceleration is negative. So in other words, the car is decelerating, and we can notice that from our graph, the shape of the graph. So again, in order to find the deceleration here, what I'm going to do, we are going to find out the gradient of the curve. To find out the gradient of this curve, again, we are going to use two different points here. So one of the points is up here at the beginning of the deceleration. So at the beginning of the deceleration, the time was 30 seconds and the velocity of our car was 30 meter per second. So this point becomes 30 and 30. At the end of the deceleration, our time was 35 seconds and the velocity of the car after decelerating was 0. So we can use these 2 points to find the deceleration of the car. So again, we know that acceleration for the given period will be equal to the gradient of that part of the graph. To find out the gradient of that part of the graph, we are using the 2 points taken from that part of the graph, and that points are 30 and 30 and 35 and 0. So calculating the gradient from this, we get 0 minus 30 as y2 minus y1 and 35 minus 30 as x2 minus x1. So this gives us minus 30 divided by 5, and ultimately the velocity we get is 6 meter per second square. Specifically minus 6 meter per second square. So the acceleration of our vehicle in that period is minus 6 meter per second square. We know that deceleration is the negative of acceleration. As acceleration is minus 6, the deceleration would be 6 meter per second. So this is our answer for A2. Now we can move on to our question number B. In question number B, we see that we have to sketch an acceleration time graph for the car in the period 0 to 35 seconds. So we have to see the acceleration of our vehicle within this time, and we have to draw an acceleration time graph for this. So we already know the acceleration for 2 periods within our graph. We know the acceleration for 0 to 10 seconds, and we know the acceleration from 30 to 35 seconds. Now we see that between 10 to 30 seconds, the graph for our velocity time graph is a flat line, is a horizontal line. We know that horizontal line has gradient 0. As the gradient of our horizontal line is 0, we know that the acceleration in this period will also be 0. And the velocity of our vehicle stays constant in this period. So the acceleration in this period will be marked as 0 in our acceleration time graph. So when we sketch our graph, we have to show 3 informations there. We know that for the period 0 to 10, we have an acceleration of 3 meter per second. For the period of 10 to 30, we have an acceleration of 0. We just saw this. And the period 30 to 35 gives us an acceleration of minus 6. And we also calculated this in our part 2 of our A question. From this, we will draw our acceleration time graph. So I'm drawing the axis. These are the axis. This is the time axis, this is the acceleration axis, and this is 3 meter per second, and this is minus 6 meter per second in the acceleration axis. And we know that our graph has 3 meter per second square acceleration for 10 seconds. So up to 10 seconds, our graph will have a acceleration of 10 seconds of 3. As the acceleration is constant, our lines are flat. Our graph will be horizontal because the acceleration is not changing and the acceleration is constant, so the lines has to be horizontal. From 0 to 30 seconds, we see that our acceleration is 0. So what we can do, we can mark it on the axis itself. We know that acceleration is 0 on the time axis. So what we have to do, we have to mark 10 to 30 seconds on the axis. Now for 30 to 35 seconds, our deceleration is minus 6. So we have to draw a flat line at minus 6 for 30 to 35 seconds. And this is our graph. This is our graph. This is our acceleration time graph. This will be the answer to our part B. Now we can move on to our part C. In part C, we have to find the distance traveled by the car for the period 0 to 35 seconds. So we know that the gradient of the velocity time graphs gives us acceleration, and there is another feature of our velocity time graph, that is the area. We know that the area of the velocity time graphs gives us the distance traveled, that is the distance traveled from the start. So if I find the area of the area under the curve for this graph, I will find out the distance traveled by the car within the first 35 seconds of its journey. And that is what we need here. In part C, we have to find the distance traveled by the car within the first 35 seconds. So in order to do that, what we are going to do, we are going to find out the area under the graph for the car. So we see that the shape made by this graph is a trapezium. So finding the area of this trapezium will give us the distance traveled. So for part C, that is what we are going to do. So we have the trapezium here. In this trapezium, we know that the area of the trapezium is equal to half a plus b into h, where a and b are the length of two parallel sides, this and this. So in our case, the length of the parallel sides would be like this. We know that the starting is 0 and the ending is 35 seconds. So the length of this side would be 35. So the length of this side would be 35. We also know that the acceleration in our first phase ends in 10 seconds and the deceleration starts at 30 seconds. So subtracting these two times will give us the length for this part, and that is 20. So we have the length of the two parallel sides. Now we have to find the height of this trapezium. To find the height, we just need to find out the final velocity after the first 10 seconds of acceleration, which was given here on the axis as, if I can see on the graph, this was given as 30. The final velocity after the acceleration is 30. So we are going to use that here. So the height here is 30. Now we're just going to use this information to calculate the area of our graph, and that will be the distance traveled. So we can write the distance traveled is equal to the area under the graph and area under the graph in this case is a trapezium, so area under the graph would be equal to half a plus b into h, and a is 20 here. This is our a, this is our b, and b is 35 and h is 30. This simplifies to 15 into 55, and that would give us an area of 825 meters. This is the distance traveled by the car within the first 35 seconds of its journey. Now for part D, we have some additional information. We see that in the part B, we have a motorcycle that also starts from the same point as the car, but the motorcycle starts when time equals to 5. The motorcycle then travels along the same road as the car and in the same direction. It is also said that for the period between 5 to 20 seconds, the acceleration of the motorcycle is a meter per second, and a is a positive constant. So between the period 5 to 20 seconds, the motorcycle is accelerating, its speed is increasing, and after 20 seconds, the motorcycle catches up with the car. So what we get from here is that when the motorcycle catches up with the car, the motorcycle is at the same position with the car. So from this we understand that after 20 seconds, the motorcycle has traveled the same distance the car has traveled within 35 seconds. We have the information that motorcycle catches up with the car. This information shows us that after 20 seconds, the motorcycle is at the same place the car is. As they both started from the same point, what this means is that after 20 seconds, the distance traveled by the motorcycle is equal to the distance traveled by the car. So we are going to use that information because in our part D, we have to calculate the value of A. And A is the acceleration of the motorcycle. So in order to calculate the acceleration of the motorcycle, we are going to use the fact that after 20 seconds, the motorcycle travels the same distance as the car does within its 35-second journey. So let us do the part D. For part D, we know that the distance traveled by the motorcycle, we know that the distance traveled by the car is 825. So what we know that after 20 seconds, the motorcycle will also have traveled 825 meters. So we are going to use that information to calculate the value of the acceleration of the motorcycle. So we know that the distance traveled by the motorcycle can be calculated using one of the constant acceleration formulas. We know some information about the motorcycle. We know that the motorcycle was initially at rest, and we also know that the motorcycle travels this distance within our 15-second period. So let us first calculate the distance traveled by the motorcycle. So in order to calculate the distance traveled by the motorcycle, we need to consider all these informations. So we have an initial speed of 0. We have an acceleration that is unknown, given as A. We have a distance of 825, and we have the time period. We know that the motorcycle travels this distance within 5 to 20 seconds. So the time period within which the motorcycle travels this distance, is equal to 20 minus 5, which is 15. So from this we can calculate the acceleration. So we are going to use an expression that connects all these quantities together, and that is S is equal to ut plus half a square. We know that S is equal to 825 from the distance traveled by the car, and we also know that U is 0, time is 15. We are substituting all the known values here, and that gives us this. So now what we're trying to do, we are bringing A on the right, on the left, and making it the subject of the formula. So we have A as this. So A is equal to 4 meter per second square. So this is the acceleration of the motorcycle that led it to travel 825 meters within 15 seconds. So this was our question number 6. We can now move to our question number 7. So this is our question number 7. We see that in this question we have two blocks, block P and block Q. Block P and block Q are connected by a string, and that string is on a pulley. We also see that the mass of block P is given as 2m and the mass of block Q is given as 5m. We see that block P rests on an inclined plane, and that inclined plane is inclined at an angle of alpha, where tan alpha is given in the question. Tan alpha is equal to 5 by 12. So from the question we see that the system is released from rest, and our block P moves up the plane. When the system is released, the block P moves up the plane and the block Q falls downwards. Now it is also given that immediately after the system is released, the tension in the string is T and the acceleration of the blocks is A. So the tension in the string is given as T and the acceleration of both the blocks and individual blocks are given as A. So now for part A, we have to write down an equation of motion for our block Q. So to write an equation of motion, we can use Newton's second law of motion. We know that for block Q, we know that there are two forces acting on it. The force of weight. Block Q has a mass of 5m, so the weight acting on the block Q would be 5 mg. We also know there is another force acting on the block Q. There is a string attached to block Q, and there is a tension in the string, which is given by T. This tension is the upward force acting on our block. So these are the two forces acting on our block Q. So we know that resultant force is equal to mass into acceleration. In our case, we know that the block Q is going downwards. So the weight is bigger than the tension force here. The mass of the block is 5m and acceleration is A. So this is our equation of motion for Q. This is our equation of motion for Q, and this is the answer to our part A. We can name this equation 1 for our future reference. Now for part B, we see that it is given that the coefficient of friction between P and the plane is 1 by 8. We know that our block P is on a rough plane, and the coefficient of friction between the surface and the block is given as 1 by 8. So for part B, we have to find T in terms of M and G. We have to find the tension in the string in terms of M and G only. So in order to do that, we need another equation. We need another equation of motion, but this time we are going to find the equation of motion for our block P. Now for P, we know that the block is on an inclined plane. We know that the mass of the block is 2m. We also know that there is a force acting up the plane, that is the tension force, and there is a force that is acting down the plane, which is the component of weight, 2 mg sine of theta. Alpha. We know that the angle the plane makes with the horizontal ground is alpha, and the component of weight acting along the plane is 2 mg sine of alpha. We see here that the weight of the block, which is 2 mg, is acting at an angle. As the force is acting at an angle, this can be resolved into two components. Our one component is along the plane, another component is perpendicular to the plane. The component that is parallel to the plane has a magnitude of 2 mg sine alpha, and the component that is perpendicular to the plane has a component of 2 mg cos of alpha. And there is also a reaction force that is acting upwards but perpendicular to the plane. So these are all the forces on our block P. Now if we want to account for the acceleration of our block P, we can use the second law. We know that resultant force is equal to mass into acceleration. The resultant force in this case is along the plane. So we will only consider forces that are along the plane, that are parallel to the plane here. So the forces that are parallel to the plane here are T, which is the tension, and the component of the weight. And we should not forget the plane is also rough. So this means that there is also a friction force acting on the block. We know that the block is going upwards. As the block is going upwards, friction force will try to oppose this motion, and the friction force will act downwards, down the plane. This is our friction force. So we also have to subtract our friction force, which I've represented using the letter F. Then on the right side, we have mass into acceleration. We know the mass is 2m, and we do not know the acceleration yet. So this is our equation of motion for P, but we need to further simplify this. So we know that the friction force is the maximum friction force in this case, and maximum friction force is equal to mu into r. As the block is accelerating upwards, the friction force applied on the block is the maximum friction force. So the maximum friction force is equal to the coefficient of friction and the reaction force on the block. The coefficient of friction is 1/8 from the equation, and the reaction force in our case is equal to the component of weight perpendicular to the plane, which is 2 mg cos of alpha. This one. From this, we can simplify this as 1/4 mg cos of alpha. So now we have the friction force in terms of m and g. So we can substitute this in here. So we have 2 minus 2 mg sine of alpha minus 1/4 mg cos of alpha. And on the right side, we have the same things, 2ma. We see that in this equation, we have sine alpha and cos alpha as two unknowns. So what we can do, we can further simplify this equation by using the values of sine alpha and cos alpha. We know that the plane is inclined at an angle of alpha, and tan alpha is given in our question as 5/12. We can derive the values of sine alpha and cos alpha from this value. To do that, I'm going to use a triangle, a right angle triangle. We know that tan alpha would be equal to opposite by adjacent sides. So the opposite side here is 5 and the adjacent side here is 12. Using the Pythagoras theorem, we can find out the length of this side, and when we do that, we find 13 as the answer. So from this, we can calculate the value of sine alpha and cos alpha. We know that sine alpha is equal to opposite side divided by adjacent side. The opposite side is 5 and the adjacent is 13. So sine alpha is equal to 5/13. So 13. Same principle applies here. Cos alpha is equal to adjacent by hypotenuse. So we have 12/13 here. Now we can use these values to further simplify our equation. So we have t minus 2 mg into sine alpha. Sine alpha is equal to 5/13. So this simplifies to 10/13 mg, and then we have minus 1/4 mg cos alpha. Cos alpha is equal to 12/13. So again, this will simplify to 3/13 mg cos alpha. Again, on the right side, we have 2ma. So ultimately, for P, we have a simplified equation that is like this. This is our equation number 2. So we see that in our equation 1 and in our equation 2, we see that in both of these equations, we have T and A as unknowns. We have two unknowns in both of these equations. So in order to solve for the value of T, we need to solve them using the methods for simultaneous equations. We need to solve them assuming they are simultaneous equations. Now to do that, we can just add the two equations up. We can just add the two equations up, and that will eliminate t, and that will give us the value of acceleration, and from the value of acceleration we can find the value of t. So what we're doing here, we are adding equation 1 and equation 2 together. We know that the equation 1 was like we know that the equation 1 was like this, and we know that the equation 2 is like this. We can rearrange them a bit so that we can understand the elimination much more clearly. So we see that adding the two equations up cancels out t, and this gives us 4mg equals to 7ma. From this we find the value of a, and that is equal to 4 by 7g. Now we can use this value of acceleration and put that into one of our equations. This is the standard process for solving simultaneous equations using the elimination method. So we are going to use this in our equation number 2. So t minus mg is equals to 2m into 4 by 7g. Instead of acceleration, I'm using 4 by 7g, and that gives us a value of 8 by 7 mg plus mg. And that simplifies to 15 by 7 mg. So this was our part B. If I summarize, what we basically did here, we tried to find an equation for our block P, and then we used that equation and our equation from part A. We used these two equations together and solved them using the technique for solving simultaneous equations. We used elimination method, and uh, then we calculated the value of t, and the value of t is 15 by 7 mg. Now for part C, we see that we are asked to state how the solution to part B uses the fact that the string is inextensible. We know that our assumption that the string is inextensible contributes to the fact that acceleration is constant. Whenever the string is inextensible, it guarantees that the acceleration uh, of both blocks would be the same. So if the string was not inextensible, if the string could extend, the acceleration of both blocks would not be the same. They would be different. Each block would have their own acceleration. As the string is inextensible, both blocks have the same acceleration, and the whole system has one single acceleration, same acceleration. So now we can move on to our part D. Now for part D, we see that it is given the magnitude of the force exerted on the pulley by the string is kmg. We have to find the value of k. So if we consider the forces at the pulley, we see that there are two forces basically on the pulley. One is inclined and the other one is not inclined. So our pulley has a string over it, and the string has a tension in it. There is a tension in the string acting in this direction, and this is acting on the pulley. It has the same magnitude as the tension we calculated in part B. And there is also the same tension force acting downwards on the pulley. So they're basically two forces of the same magnitude acting on our pulley. The forces are like this. Now it is given that the resultant of these two forces is k mg, we have to find out the value of k. So to do that, what we can do, we can find out the resultant of these two forces, and then we can compare to find the value of k. So now, in order to find out the resultant of these two forces, what we can do, we can form a vector diagram using the head-tail method. So using the head-tail method, the resultant of this two vector would be like this. So we are using the head of one of the vectors and joining it to the tail of the other one. So both vectors have the same magnitude. Now adding them up, the resultant of them would be like this. What we have to do now, we just have to find out the magnitude of this resultant force. When we find the magnitude, and that will give us the value of k. We can just compare and then we can find the value of k. So we know that tension is given as 15/7 mg. We calculated this in our part B. So from this we see that the magnitude of these two sides are 15/7 mg. And this side has also the magnitude 15/7 mg. So in order to find the other side, in order to find the magnitude of this side, what we have to do, we have to use some triangle theorems to find out the other side. So what we can do, we can use the angle between them and then use cosine rule to find out the other side. So now, in order to use the angle, we need to know it. So at first we have to see that what angle forms between these two vectors. So we already know that the plane was inclined at an angle of alpha. We already knew that the plane was inclined at an angle alpha. So the pulley sits on the other side. So this angle will be equal to 180 minus 90 degree. The 90 degree is from this side minus alpha. So basically this angle will be equal to 90 minus alpha. So we know that the angle between these two vectors was 90 minus alpha. But this is not the configuration we have here. So what we need to do, we need to see that what is the angle between these two vectors. So in the configuration here, what I have done, I have taken this vector upwards. I'm just taking these vectors in this direction. So I can move it here. We have a plane here, and I can just move our vector here. Now we need this angle. So we can see that these two lines are perpendicular. We see that these two lines are parallel to each other. As these two lines are parallel, this angle and this angle would be allied angles. So the required angle here, the angle between the two forces would be equal to 180 minus 90 minus alpha. We see that these two angles are allied angles. So what can we do? We can find out this angle by subtracting 180 degree, by subtracting this angle from 180 degree. We know that when two angles are allied angles, adding the two allied angles gives us 180 degree. So if I want to find one of the angles when the other angle is given, I can subtract the other angle from 180 degree, and that gives us our required angle. So simplifying this, we get 90 plus alpha as our required angle. So we see from here that the angle between the two forces is 90 plus alpha. If I draw this in a larger way, we have the force T, and we have the same size force that is acting in this direction. This has a magnitude of 15/7 mg, and this has a magnitude of 15/7 mg. The angle between them is 90 plus alpha. We already calculated this. we calculated 90 plus alpha from the original configuration. In the original configuration, the angle between the two forces was 90 minus alpha. So when we changed the configuration, we saw that the angle between the forces in the new configuration and the old configurations, both of them are allied angles. So we can add them up and get 180. So we used that fact to find out the angle in the new configuration when the forces are joined using the head-tail method. And now we can find out the resultant force. So this is our result. This is our resultant force. We can find out the magnitude of the resultant force using cosine rule in this triangle. So we have this triangle. We have two sides that are known, and we have an angle that is between the two sides, and we can use cosine rule in this triangle to find out the value of our resultant force. So we are using cosine rule. By cosine rule, we know that the resultant force, this side, will be equal to root over the square of the known sides. So 15 by 7 mg whole square plus 15 by 7 mg whole square minus 2 into 15 by 7 into 15 by 7 mg into cos of alpha. Sorry, into cos of 90 plus alpha. So now this will simplify to so from this we have root over of 450 by 49 m square g square minus 450 by 49 m square g square into cos of 90 plus alpha. So if we think about this quantity, if alpha is an acute angle, let's say alpha is an acute angle, so 90 plus alpha would be here in the second quadrant. 90 plus alpha is a second quadrant value. So we know that cos alpha is negative in the second quadrant. In the second quadrant. So in order to find a simplified value for cos 90 plus alpha, we can use the we can use the addition formula for cos alpha. We know that cos a plus b is equal to cos a into cos b minus sin a into sin b. We can use this for cos 90 plus alpha. So we have cos 90 plus alpha here, and cos 90 plus alpha can be broken down using the addition formula for cos a plus b. So we have cos 90 into cos alpha minus sin 90 into sin alpha. Now simplifying this, we know that cos 90 is equal to 0. So this whole term becomes 0. So we have 0 minus sin 90 into sin alpha. We know that sin 90 is equal to 1. So 1 into sin alpha is equal to sin alpha. So what we see here that cos 90 plus alpha is basically minus sin alpha. So we can use this here. The reason we require this simplification will be clear in just a second. So we have minus sin alpha here, and that simplifies our expression to 450 divided by 49 m square g square minus, I'm sorry, this will the minuses combined to form a plus, and then we have 450 divided by 49 m square g square. So see, we have sin alpha here. We already know the value of sin alpha from the previous parts of our question. We use the triangle to find out the value of sine alpha, cos alpha, and tan alpha was already given. So we can use one of these values, especially the sine alpha one, to calculate this. So we saw that sine alpha is equal to 5 by 13. I'm going to use that here. So this was the reason for our simplification. When we simplified this, simplified the cos 90 plus alpha term, it made us a convenience here that we can use the sine alpha value directly. So now upon simplifying this further, that will give us a value so this gives us a value of 90 root 13 divided by 91 into m and g. The root on m square and g square term simplifies m square g square to mg. So we have this here as such, and we have from the question the resultant force. We know from the question that the resultant force was given. We already know the resultant force was given as kmg, and this is from the question. So we can now compare these two values, and we see that k is equal to 90 root 13 by 91. We can also write this as 3.57 in decimals. So this is our answer to part C. So a brief summary for this would be, we use the two forces that are on the pulley to find the resultant force of the pulley. The angle between the two forces was 90 minus alpha in the previous configuration. When we change the configuration, when we rearrange the forces using the head-tail method, we calculated the angle between the two forces again. We saw that in the newer configuration and the older configuration, the angle between the two forces were an allied angles. We know that allied angles add up to 180 degree. So we used the older angle and subtracted the older angle from 180 degree to find the newer angle. And then we used that angle to find the resultant force. So this was our part D here. Now this concludes our question number 7.